Hello, I'm Debashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solution. And today's topic for webinar is real world AWS architecture patterns for high availability and scalability. What does it mean by high availability? High availability means that always your resource is available in the cloud. Say, for example, you are having any potential, say, data failure, say you are not having any backup. So in that case, you have to keep a backup, say in the S3 bucket or the EBS volume, then you have to do that. Otherwise, your data you cannot recover. And scalability means what? That I will also discuss. So let's start. So we'll discuss the best practices for high availability and scalability in the AWS cloud. So we'll explore the designing resilient AWS architecture that ensure high availability and scalability. High availability means that there should be a robust cloud infrastructure that can withstand failures. Yes, that if there is a data loss, say for example, the cloud server has failed. So in that case, how can you recover the data? If you haven't backed up the data in some other external location, say for example, if you haven't backed up in the S3 bucket, if you haven't backed up the data of the EBS volume, then it would be disaster for you because you have migrated your entire data to the cloud data center and now you cannot recover it. So definitely you should have a resilient infrastructure, robust infrastructure for the high availability, that your data should be always available. The downtime should be zero, and also the scalability to improve your performance, because the load on your cloud server, on your data center, is always going to increase. So you should have the scalable infrastructure. Means not only one cloud server, but there can be n number of servers. If you are having too much load on one server, then that entire server may fail. So, to avoid the situation, you should have a scalable infrastructure where you are having multiple servers. We'll understand the resilience. What does this resilience means? Resilience in AWS architecture refers to the ability to recover from failures and continue operating. So the key aspects are fault tolerance, like the backup, that if there is, like in a server, there is no RAID configuration. So what will happen? There is only one hard disk. So if that hard disk fails, the entire data is lost. So in that case, we configure what? We configure the RAID. So we actually install the multiple disks there. So one disk doesn't contain the entire data. It is backed up in several hard disks. So there is a software RAID, and also we have a RAID controller that is in the part of the hardware RAID. So these things constitute the fault tolerance feature, self-healing, and data redundancy. So you have to implement these principles and practices to ensure minimal downtime that I was talking about. The downtime should be zero and consistent performance. Because, say, for example, if you have hosted a website on an S3 bucket and it has failed, so your website will stop and definitely you will incur a lot of loss. So, definitely to mitigate that situation, you have to have a resilient infrastructure and high availability. So, what is the basics of the high availability? It means that ensuring applications are operational and accessible at all times, everywhere. Always it is accessible. It is not down even for a single minute or single second. Because nowadays we cannot think without the cloud. You go for any app, any IoT device, anything, it is dependent on a cloud. From every app that you download from the Play Store, it depends on the cloud infrastructure. And now, if the cloud has the downtime, then our business will fail. Now, this high availability can be achieved through multi-AZ deployments. Now, you are not having a single availability zone, but you are having multi availability zones like the multi cloud. Then you have the load balancers, which actually balance your traffic or load among the multiple targets or the multiple EC2 instances, and auto scaling. If one server is getting too many hits or too many, say, network traffic, then it will distribute that load in multiple servers. So multiple nodes will be automatically created. It can be the horizontal scaling, like the number of history instances will increase, or it can be the vertical scaling, like the number of the hardware resources, say the CPU, number of CPU, number of hard disks, RAM capacity will increase to handle unexpected traffic spikes and hardware failures. Now, what is the scalability? Scalability is the ability to handle increased loads without compromising performance. So, definitely, a lot of load may come on the cloud server. Say, for example, you have announced a sale period of 2 or 3 days. So, during that sale period, definitely AWS will actually experience a lot of traffic on their servers and more traffic than the normal times. Now, in AWS, this can be accomplished using horizontal scaling that I was talking about, that adding more instances, and it will be done automatically. Yes, if you have to plan it, that say, for example, on one instance, the CPU percentage is more than 50%, then you will have two more instances or three more instances running automatically to actually distribute the load among the instances. Or it can be vertical scaling, like the increasing the capacity of existing instances. Capacity means hardware resources based on demand. So this is mean by the scalability. Again, you can implement the elastic load balancing ELB feature also, that distributes incoming application traffic across multiple targets. Targets are the EC2 instances. So when the traffic is coming from outside, so it is hitting the load balancer, and the load balancer is attached to the VPC, the virtual private cloud, and the load balancer is distributing the traffic in across the multiple target instances. This improves fault tolerance and availability, and it ensures that no single instance becomes a bottleneck or point of failure in your architecture. So because if the one instance is getting all the traffic always, then definitely it is serving the 100% load, and definitely it may fail. So you are distributing it among all the instances, so this is not happening. Now, how to implement the auto scaling? AWS auto scaling helps maintain application performance by automatically adjusting the number of instances based on demand. So you have to implement the auto scaling. You have to run one instance, that is your primary instance, and then you have to take some image of that instance, and then you can implement the auto scaling feature. This ensures that you have the right amount of resources available at any time, optimizing cost and performance. Now, you should have a proactive data backup strategy as well. To enhance resilience, implement effective data backup strategies. Use services like Amazon S3 for object storage and AWS backup for centralized backup management. So Amazon S3, simple storage service, there is a bucket that we have to store the data inside the bucket. And AWS backup is also a method that you can use to take the backup of your S3 instances or any data. So you should have this in place to implement the effective backup strategy. Regular backups protect against data loss and ensure quick recovery. Now, multi-region deployments. Deploying applications across multiple AWS regions can significantly enhance availability and disaster recovery. Now, this strategy mitigates the impact of regional failures and ensures that services remain operational. So, you cannot deploy on one region, because if you are dependent on one region, definitely it is a single point of failure. So you have to make sure that you distribute the resources in multiple regions, or at least in multiple availability zones, because there can be localized outages. So say, for example, one data center in one place of the globe has failed. So what will happen? Your entire data, your entire resource will be unavailable. So in that case, it will be very bad for you and your organization. So what you need to do, you need to actually deploy a multi-region deployment strategy. Again, monitoring and alerts play a very crucial role in this cloud environment. You have to implement robust monitoring and alerting system like the Amazon CloudWatch to track the performance metrics and set up alerts for unusual activity, because the cloud server may always fail. So you have to just realize the warnings. You have to analyze the warning and log all these things to actually, say, for example, forecast the health of your cloud server, enabling proactive management of your resources. What are the security best practices for this cloud? Security is integral and paramount to cloud security. For the resilient architectures, implement AWS Identity and Access Management IAM. That is also very crucial for implementing the access control in the cloud. Use encryption like the KMS for data protection, and regularly you have to audit your environment to identify vulnerabilities because there can be any outside attack. So to prevent that vulnerability, you have to implement a robust security mechanism. Again, cost optimization techniques should be there. While designing resilient architectures, you have to consider the cost optimization. And for that, you have to use the cost explorer to analyze the spending patterns, take advantage of reserved instances, and implement saving plans to reduce cost. Because in cloud, the main part is to reduce the cost. If you are incurring too much cost, then it doesn't make any sense to actually store your data in the cloud. So for that reason, you have to implement a robust cost mechanism, and also you have to calculate the AWS cost, and the cost optimization is one part of that. So we can conclude that designing the resilient AWS architectures requires a focus on high availability, scalability, and security. So there is not a single point in the designing of a robust architecture. It is actually combining all these three features like high availability, scalability, and security. By implementing these best practices such as auto scaling, load balancing, and effective monitoring, organizations can ensure robust performance and scalability. So these things are actually implementing in the cloud to ensure best performance and reliability in the cloud infrastructure. So this is about the theory part about this AWS resilient architecture. And now I can take you to the AWS console here, and where there are many services that you can see. And one of it is the, say, the EC2, where you have the all the instances, and you can see the auto scaling here. You can as well as see the load balances also. So what you need to do, you have to create the auto scaling groups. So here you can see that in auto scaling, say for example, this is auto scaling group. Now there are three things here. One is the minimum size, other is the desired capacity, other is the maximum size. So how it works? So you have to make an auto scaling group, and you have to define the number of instances there. Minimum is say for example, I have defined one instance, that is a minimum instance. Then desired capacity, desired is 2, and the maximum it can scale out if it's needed as 2 more instances. It means that by default 2 instances, that is equal to your desired capacity, the 2 instances will be launched by default. But if the load increases, then I have to specify the factors. It can be the CPU load, it can be the hard disk, it can be the say the network input output of the IO. So it can be any factors, and you have to specify the value for that. Say for example, if the CPU load increases beyond 50%, say for example, then your scaling will happen. And scale out means that 2 more instances will be running. It will be launched. There are two things. One is scale out, one is scale in. Scale out means that your number of instances, if you are going for horizontal scaling, the number of instances will increase. And scale in means that it will decrease. Say, for example, the load on the issue instances has decreased. So definitely you should implement the scale in approach, means your auto scaling should stop. Otherwise, you have to incur unnecessary cost. So this is the way it works. And there you have to create an auto scaling group here. You have to give a group name, and here you have to specify a launch template. Now what is a launch template? Launch template, if you go for the create a launch template, so launch template can be created from the running S3 instances. So here I do not have any of the launch template. So what you can do, you can take the AMI, you can take the Amazon machine image of a running instance, because you need one running instance there. So, and based on the running instance, you have to implement the auto scaling. Like that will be the point where you will implement the auto scaling. Because say for example, you have a Windows Server 2019 or 2022 server instance running, and you are having an AMI of that. So that AMI will be actually included in this launch template. And then you have to implement the auto scaling on that. So first you need to go to the EC2, that I can show you the steps here, and you have to create an instance here. And when the instance will be actually running, in that case, and you have to take the AMI. So the first step is that you have to run an instance, then you have to take the AMI, and then you can go to the auto scaling group, and you can create the auto scaling group, and then you can select the launch template. Like the template one is here, which was created earlier. So you can see that launch template is already there. So you just click on the next, and you select the VPC and the availability zones. You can select any availability zone there, and there, so it doesn't have the template because I think the templates was actually deleted. So the template doesn't have, because I deleted the template earlier. But if you actually have any launch template, because here it is only the name is showing you, but the template is not there. So here you can also implement the load balancer with the template. If you want, you can go for balanced only, or otherwise you can go for balanced best effort. And there, if you actually have a template, there you will see the auto scaling rules. They will see the auto scaling rules in this configure group size and this scaling. So here in the group size, you have to specify that minimum instance, desired capacity, and the maximum that I was talking about. So if you have made a launch template, then you can do these things. And then if you complete that, then you'll see that by default two instances will be running, because you have specified the desired capacity as 2. And if the load increases, then it will be, say for example, 4 instance. If you have specified maximum as 4, or you have specified as 5, then 3 more instances will be launched. So this way you can actually implement the auto scaling. So that is the method to do the auto scaling that I told you. And in load balancer, here also you can implement the load balancer. So you have to create the load balancer here. So I'm showing the options, that is application load balancer. It is actually involving the directly the applications like the HTTP and HTTPS protocol. Or the network load balancer, it is actually having a broader approach like the TCP, UDP, or TLS protocol. And gateway load balancer, it is a separate thing where it is implemented to the gateway, like supporting your firewalls, all these things. So you can implement any two of this load balancer, and classic load balancer is previous generation, it is no longer used. So say for example, you can create the application load balancer, and definitely it would be the internet facing load balancer, because you are having the public IP. Internal means that is your private load balancer in your organization, it is having the private IP. And here you are having the dual stack IPv4 option. Dual stack means if you're having IPv4 and v6 together, then you will have to select dual stack. Otherwise, if you are only having IPv4, then you can go for IPv4. In case of network mapping, just remember that you have to choose at least 2 availability zones, because AWS recommends that load balancers should be included in at least 2 or more AZ, not in one AZ. And security group, you have to specify any security group that you have created earlier, or you can create one security group. And now you have to specify the target group. Target group means that you have to add the instances. So previously you have to launch some S3 instances, and then you have to add these instances in the target group. So you have to give a target group name, any name, and then you have to specify the protocol. This is the protocol here. Different protocols are available there. TCP, TLS, different protocol, and port number, and IP for IPv6, VPC, and protocol version. Like here, HTTP, HTTP1, HTTP2, these versions are here. And you can click on next. And here, no instance is there, no target is running because we are not running any instance. But if we are running an instance, then you have to select here the instances that will be included as a target in the target group of the load balancer. So load balancer will distribute the traffic among the multiple target of these two instances there. And then you have to click on the finish, and the load balancer will be deployed. It will be in the provisioning state first, and then it will perform a health checkup of the target nodes. And if the target nodes are responding properly, then definitely the load balancer will be active. And this is a public load balancer, so definitely it should have a public IP, and so definitely it is costly for you. So just make sure that you do not run load balancers unnecessarily. So that is the way we can balance the loads also in the AWS. So these are the different tools to implement the resiliency and the high availability fault tolerance there. To distribute the load, to take the backup, you can take the backup in the S3 bucket also, and also this auto scaling to actually do the scalable infrastructure in the AWS. So these are the tools for AWS architecture. For any cloud, you should have this high availability and scalability for high performance. Without these tools, definitely your cloud infrastructure cannot survive the outside attacks or any high demand, because definitely the cloud nowadays is in very high demand. All the applications are actually being migrated to the cloud, and say the routers, switches, firewall, load balancers, everything is slowly but definitely moving towards the cloud. So you have to make that cloud highly available, scalable, and secure environment. So I hope that you have got an immense understanding on this topic of high availability and scalability of the AWS infrastructure. And I thank you all for joining and watching this topic. And I hope it will be very helpful for your career and the study for the AWS Solution Architect examination. I will come with some new topic next time. Till then,